Welcome viewers. In this video we are going to model transmission line tower in STAAD.Pro. In this we are going to model 400 kV single circuit horizontal configuration tower. So this is a stage 1 of 3. In this we are going to see a schematic drawing of this horizontal configuration tower of 400 kV. Excel calculation for node positions in STAAD.Pro, node creations in STAAD, body cage, boom and peak member creation in STAAD.Pro, support condition in STAAD.Pro. In the right hand side you can see the 3D view of this horizontal boom configuration of 400 kV single circuit tower, and this is in the middle lower you can see the plan at the boom view. These are the typical hip bracing view in the top of middle. So let me see the schematic drawing of this 400 kV single circuit horizontal configuration tower. So here is in the left hand side it is a transverse elevation which is perpendicular to the span of conductor. Next one is a longitudinal elevation. In the right hand side top it is a plan at boom. Section 1 and section 2 are in the right hand side bottom view, where the section are taken in the transverse and elevation longitudinal elevation at 3 meter and 5.5 meter. So here the boom height is 20 meter, gauge height is 8 meter, boom depth is 1 meter, above that peak is 3 meter. So similar like in the transverse and the longitudinal elevation, the same dimensions are adopted. Only thing, the view of both directions are different, whereas in this case you can see the gauge which is having a 2 level of direction change. This is a mid of the gauge. From the top of the body up to 5 meter, the different method of gauge, and above the 3 meter there is a different way of gauge which is holding the boom. So this space is mainly for the purpose of conductor to be run in between this space. The face to face distance is 7 meter. So it means the total span of the boom is 14 meter. This boom is divided into 1 meter segment for cross bracings. From the center line to the peak it is 4 meter. Also the leg members to be spliced at various level between 6 meter to 12 meter, where the 6 meter and 12 meter is based upon the available steel sections with the fabricator or steel manufacturer. Generally the 6 meter or 12 meter is available with the fabricator. In some of the fabricator used to have only 6 meter, so we need to make the splicing accordingly. So here we can consider the critical span of any steel section is a 6 meter, so that first leg member should have less than 6 meter and all the leg member to be subdivided like that. So this is a plan at boom, whereas the edge of the boom is having 1 meter wide and the connecting point it is having 4 meter. These are the section 1 and section 2 of explaining the hip bracing. And in the plan The gauge distance is 4 meter and the boom width is 2 meter. So let we start our modeling in STAAD.Pro. So this is a landing page or first page of the STAAD while we are opening the STAAD window. In this we need to check first the unit of measurement which we are going to model it. Here we are going to do in metric only. So we need to find out whether this node table is updated with the metric unit of measurement. Here you can see X, Y, Z are mentioned as a meter as a unit of dimensions. If it is not found, if suppose it is in inches or feet, we need to check here in the geometry. We need to change those unit of measurement by clicking this tab input units. So in that there are three parameters: English, metric and custom. So whatever is required for our modeling purpose, we need to select it. So here we are going to do it in metric. So in length we need to change this as meter, and in force we need to click this kilonewton and click apply. If you are going to do in English or inches and kilopound, you can select like this and give apply. You can see here this unit of measurement is changed to inches. So likewise we need to fix this unit of measurement based upon our model. So this is the first step, we need to do it. So this is a Excel sheet which we need to develop for node positions. So these are the parameters we record, structure parameters. First is the dimensions of boom. Boom fixing height from ground is 28 meter. You can see in the right hand side picture. So 20 plus 8. So here the boom is going to fix. Next one is body height from ground is 20 meter. And gauge height from ground, sorry, it should not ground, from top of body is 8 meter. Span of boom from center line of tower, so this dimension. Width of cross arm at the tower, so you can see here this width is a width of cross arm tower. Width of cross arm at edge is 1 meter. We are considering this. Boom width at the connection to tower gauge left and right. So boom width is 1 meter at the left and right side of edges. So this is a dimensions. Similarly, dimensions of tower, top width of body is 4 meter. Here this dimension, and bottom width is 8 meter. You can see at the bottom. Peak height from bottom of boom is 4 meter. From here 1 plus 3 it's 4 meter. Cage change level from cage bottom. So from here to this level is 5 meter. You can see here 1595, 1500, 1905. So summation of this will come as 5 meter. Total height of the structure is 32 meter. So these are the dimensions we need to enter here. And to create the join coordinates in STAAD, we need to have X, Y, Z. So here you can see Y direction is in vertical, X direction is in longitudinal elevation, Z direction should be in transverse direction. So likewise we need to create the nodes like this. So first point we are going to start at this area, this node. So this we can call it as 0, 0, 0. From 0 it should go to 8. Yeah, this is a 0, 0, 0. From 0, 0 to it is 8. So likewise this 4 node to be created for base. And similarly like bottom cage level. The height that is in y direction, it is 20. You can see here, and x and y to be do like this. So it is 2. 2 means from this point to here it is 2. From 2 plus 2, 2 plus 4 is 6. After that 2 to create from here. So likewise this node to be created. So it is a simple calculation for cage left change, that is at here left and right we are having a height 20 plus 5 meter, and similar like this x direction we need to calculate like this. It is a connection to tower or cage, this area. So likewise all the node to be calculated. There are 24 major nodes which you need to calculate like this by applying simply geometric formula. Here that boom, left side boom should go minus 3 meter because it is totally from center line it is 7 meter. We are already having base node from center line is 4 meter. So this is 7, this 4 meter minus 7 will have minus 3. So likewise we need to prepare this node calculation. So after doing this, what we can do is we can just copy and paste to the STAAD model. So just we are copying this, go to STAAD model and click this node tab in the right hand side and paste here. Here it is asking first column should be node, yes. Second column is x direction and third column is y direction and fourth column is z direction. So you can also change this if it is not selected like this. So what we got selected in this Excel is node number XYZ only. So same parameter. So we can click OK. So those nodes are created here. You can press Shift N to view the node numbers. Next one is we need to go for 13. So here you can select from the XYZ alone instead of copying from the node. What we can do is we already selected this 13. You can paste here. Again it is asking like this. So here you can change this to node to X because we had selected only the XYZ instead of selecting the node as per earlier. So this first column could be X and the second column should be Y and the third column should be Z. So just to click OK. You can able to see the nodes of boom also. So now it is easy for us to draw the node members which are connecting the node number. So in the right hand side you can see the picture, 2D picture which we are going to model it. So now we can draw the members, go to geometry, add beam, connect these nodes of leg members. So likewise do it for all the members. So this is a gauge main member which we are drawing now. So this is a tie member of gauge and body. So next we need to connect these node numbers. 9 and 13. Similar like 9 to 14. 15 to 10 and 16 to 10. 12 to 19 and 12 to 23. So you can see here. So this is matching to the right hand side picture of transverse elevation. So now we need to connect the boom. You can draw like this. So we are drawing the bottom of bottom card and bottom tie of boom. So we need to draw the possible members. So this cross bracing also possible. So now what we can do is we can copy paste this members for top card of boom. So from the sketch you can see that distance between the top and bottom card is 1 meter. So what we can do is we can press Ctrl C, copy, Ctrl V in the keyboard so that you can see this window. In this Y we need to type 1 meter, as you can see in the sketch right hand side that it is a 1 meter. So now we need to select this node, this member, and edit here the point 25 should be 21, and similar like for this member 31 should be 22. So now we can delete this member which is not required and the node also. So similar like for the right hand side, this 30 should be 23. Also this 36 to be 24, and delete this member and the nodes. So now we can view this. So it is nearly matching to the right hand side picture of transverse elevation. So now we are going to draw the peak members. So to draw the peak member, just go to click this select and node cursor, select this 26 and 29 nodes, press Ctrl C, copy, and Ctrl V in keyboard, paste. So in this you can see in the right hand side picture the peak is 3 meter from the top card of boom member. So we can type here 3 and click OK. So now select this node. So you can find the node which is showing here 36, that x direction is 3 and 32 it is 5. So 3 plus 5 divided by 2 it is 4. So we are taking average. This 36 should come in the middle of this 26 and 32 node. So for taking the average it should be 5 plus 3 divided by 2 it is 4. So directly you can enter here 4 so that the node will come at the center point of this 26 and 32. Similar like this 37 should come between 29, that is 3, and 35 is 4. So this is also to be 4, average of 3 and 5. So then we can draw beam member, that is peak member, from here to connecting this. So likewise we need to draw the 4 members. All the 4 members are drawn now. So these are the peak members. Also we can draw this boom vertical tie. Also the cross bracing of this boom at the tower connection point. So we can draw whatever the possible members. So now we can view transverse direction. So all the main members are created now. Even in the longitudinal view also you can see the view which are nearly matching to the right hand side picture of longitudinal views. So is there any other member is possible to draw? We can check it. So now we need to create the support condition. So click here specifications, click pinned, add, select this S2 type which is pinned, and view, select this bottom nodes 1, 2, 4 and click here assign. Yes. So now you can see the support conditions are also assigned. So with this we can stop this stage 1 of 3. We will see how to create the bracing member in stage 2. Thank you for watching. Look description for more related video. Subscribe to this channel for more updates. Thank you.